NASA launched Mariner 4 on a flyby mission to Mars in 1964. While passing Mars 7.5 months later, it returned the first close-up images of another planet, and its sensors provided a preliminary look at Mars's magnetic field, atmospheric density and composition, and radiation environment. Since then, extensive research has been conducted both in orbit and on the surface, providing further insights into the red planet and its history. In total, humanity has attempted 50 missions to Mars. Approximately half have been considered successful. There are currently 11 active probes surveying Mars, consisting of 7 orbiters, 3 rovers, and 1 helicopter. Let's take a look at what they've been up to over these last few years. Orbiters play a number of crucial roles in support of rovers, such as mapping the surface in search of locations of interest, identifying safe landing areas, and guiding the landers during descent. Once the rovers are on the surface, orbiters provide key communication relays between Earth and Mars. However, orbiters do much more than just support surface missions. Some notable achievements of the currently active orbiters include Odyssey's finding that substantial amounts of hydrogen exist just below the Martian surface. This indicates the presence of large amounts of water ice within reach of future Martian colonists. Europe's Mars Express orbiter discovered that 15% of Mars's south polar ice cap is in fact water ice, despite it previously being believed to consist entirely of frozen carbon dioxide. The Mars Reconnaissance Orbiter has provided thousands of images of Mars's surface, giving insight into the history of Mars and providing evidence of recent water flows on the planet's surface. MAVEN has shown that during solar storms, deterioration of Mars's atmosphere increases significantly, and surface radiation levels can double. This knowledge helps NASA researchers to predict as well as mitigate the effects of radiation on future human Mars explorers. The ExoMars Trace Gas Orbiter is currently searching the Martian atmosphere for evidence of methane gas. Very small quantities of methane were previously reported by other orbiters, but it's not certain where it came from or what produced it. Methane is of particular interest because it could be a sign of microbial life existing below the surface. The HOPE probe is studying daily and seasonal weather cycles, including events in the lower atmosphere such as dust storms, and how the weather varies in different regions of the planet. There's also China's Mars Orbiter, which was part of the Tianwen-1 mission that delivered the Churong rover to the surface in May of 2021. After supporting the rover in its preliminary mission, the orbiter began to focus on its own data collection. Despite some speculation from earlier in the year that the orbiter suffered a communications glitch, China recently released a new global map of Mars's surface composed from images taken by their orbiter. In the near future, Odyssey plans to perform new thermal studies of rocks and ice below Mars's surface, as well as continue its long-running climate monitoring campaign. While MAVEN will study radiation levels on Mars as the Sun approaches solar maximum in 2024 and 2025. Future planned orbiters include India's Mars Orbiter Mission 2, which is scheduled to launch by 2024 to teach us about the early Martian crust, and NASA's ESCAPADE orbiter, also planned for launch in 2024, which will gather additional information about Mars's magnetosphere and its interactions with solar wind. So now that you know a little bit about the 7 orbiters around Mars, let's take a look at the 3 rovers and what they're up to. The Curiosity rover landed on Mars in 2012. Equipped with 17 cameras, a robotic arm, and a suite of specialized tools and instruments, it's found that for much of Mars's history, it would have been suitable to support living microbes. The main questions remaining are, did life in fact form, and if so, is any of it still alive today? In pursuit of these answers, Perseverance was launched in 2020 to look for signs of life. In addition to exploring Martian geology and assessing ancient habitability, Perseverance has been collecting samples of rock and regolith in hopes that they can be returned to Earth by future missions. Another NASA rover, InSight, was launched 2 years prior in 2018. Its goal was to uncover how a rocky body forms and evolves into a planet by investigating the interior structure and composition of Mars. The mission hoped to determine the rate of Martian tectonic activity and meteorite impacts. Unfortunately, after Martian dust was deposited onto its solar panels, it stopped working in December of 2022. Speaking of deceased rovers, remember China's Tianwen-1 mission from earlier? Observations by NASA's Reconnaissance Orbiter show that the Churong rover hasn't moved since it was put into hibernation mode in May of 2022, despite being scheduled to wake up last December. There is some hope that the summer sun could revive it from its slumber, but right now it's looking like the Churong rover is the latest robot to have met its dusty demise on our red neighbor. Remember when I said there was a helicopter on Mars? The Ingenuity Mars helicopter was sent to Mars to perform experimental flight tests to determine if powered, controlled flight in the Martian atmosphere was possible. Despite the atmosphere being less than 1% as dense as Earth's, thanks to its large and specially shaped blades and ultra-fast rotational speeds, it's already performed more than 400 flights in the Martian atmosphere, and sent back plenty of aerial images to guide the Ingenuity rover to new and interesting locations. These robotic missions have led to a lot of new knowledge of the planet Mars and how humans could one day live there. The MOXIE experiment on board Perseverance successfully tested a technology for extracting oxygen from the Martian atmosphere. This provides another way for mission planners to use Mars's natural resources to support future human missions. Both Curiosity and Perseverance have instruments on board to measure the amount and kind of radiation future astronauts will be exposed to on the Martian surface, so that proper shielding and mitigative strategies can be developed. Rovers have been monitoring weather and dust in the Martian atmosphere to better understand daily and seasonal changes. High-resolution images have been taken of surface features, and the rocks and soil have been studied to better understand what the surface is made of and how it could be used to support a growing Martian civilization. The European Space Agency plans to launch the Rosalind Franklin rover in 2028, which will use a variety of instruments to better characterize the nature of water ice on and below the surface of Mars. And NASA's Mars Sample Return mission, planned for 2031, will build off Perseverance's current efforts by actually bringing some samples back to Earth for further study.